Hello everyone, I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system. Several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Hello, hopefully the sound's coming through all right. Any thumbs up? No. I think I've got a thumbs up. So hopefully the sound volume's all right. I usually sometimes have problems with this. And so welcome to another Saturday talk from John Chappell Natural Philosophy Society. Today's talk, I'll just bring it up. Hey, that's brilliant. So today's question being raised, has antimatter been misunderstood by the mainstream ? Everything is really, what mainstream physics has is really based upon Einstein's ideas, starting with Einstein's relativity, and it's all been built upon that. And even when people say that quantum physics is different, some of the ideas of relativity have gone into quantum physics. So everything has a sort of beginning with mainstream physics. It's coming from Einstein. And so they build all these ideas, one on top of the other. And I've done many talks now complaining about relativity. And so it just carries on that there's more things built on top of it, and it's more things to complain about. This time it's complaining about antimatter. Has it been misunderstood by the mainstream based on what they believe from Einstein's relativity, i.e. from his influence on physics? So we get started now on this. So basically it's really just another whinge about Einstein's relativity, but dealing with that antimatter this time. And I have got a video to show, and hopefully I will be able to get to show that properly this time, because there's so much problems with the getting the sound to come through on these things. Hopefully I got on top of that. Next slide. So if we go to Wikipedia, it does give you an outline of what antimatter is, and this is what Wikipedia says. It points out the modern theory of antimatter. The modern theory of antimatter began in 1928 with a paper by Paul Dirac. Paul Dirac realized that his relativistic version of the Schrödinger wave equation for electrons predicted the possibility of anti-electrons. Anti-electrons are antimatter versions of electrons, and sort of Schrödinger's equation is one of the main equations of quantum physics, and so Dirac was combining relativity, well, attempting to combine relativity with quantum physics. And generally, it's not thought that that's been successful. Sometimes physicists will say that special relativity has been combined with quantum physics, but they've had problems with trying to combine general relativity to quantum physics. So it's not been an entirely successful venture from the mainstream when they've tried to combine relativity with quantum physics. But anyway, Dirac had a go at it in 1928, and he came up with his version of antimatter, which is pretty much the modern version of antimatter after a few changes. And it says, Wikipedia says, although Dirac had laid the groundwork for the existence of these anti-electrons, he initially failed to pick up on the implications contained within his own equation. And he freely gave the credit for the insight to Oppenheimer, whose seminal paper, which was on the theory of electrons and protons in 1930, drew on Dirac's equation and argued for the existence of a positively charged electron. Positron is just really another name for anti-electron, which, as a counterpart to the electron, should have the same mass as the electron itself. So you've had the initial idea coming from Dirac, with the modern version of antimatter coming from Dirac in 1928, and then, in my view, the theory got changed a bit in 1930 by Oppenheimer. And then that's sort of like normal way, in my view, that modern physics is being done. They sort of modify ideas a bit. But anyway, that is the modern theory of antimatter. And Wikipedia admits the idea was around before that. It says, the term antimatter was first used by Arthur Schuster in two rather whimsical letters to Nature in 1898, in which he coined the term. He hypothesized anti-electrons, which is antimatter as well, antimatter versions of atoms, as well as Hall antimatter solar systems, and discussed the possibility of matter and antimatter annihilating each other. So even before the modern version of antimatter came from Dirac, the idea of antimatter was around before that. And it points out it differed from the modern concept of antimatter in that it possessed negative gravity. So from the early version of antimatter in 1898, when it came to Dirac and Oppenheimer, the theory got changed a bit. And it points out, Wikipedia points out that even before that had related ideas. Wikipedia says the idea of negative matter appears in past theories of matter that have now been abandoned. Using the once popular vortex theory of gravity, the possibility of matter with negative gravity was discussed by William Hicks in the 1880s. Between the 1880s and the 1890s, Carl Pearson proposed the existence of squirts and sinks of the flow of ether. And so in that context, you were having an ether theory. And surprisingly, with this person, Carl Pearson, he was saying similar ideas to what then get later credited to Einstein, and when this paper in 1905. So mainstream physics sort of like discards the prehistory before modern physics, which starts about 1905 with Einstein. They sort of ignore that the ideas were around before then, and particularly they sort of ignore the idea that before Einstein there was this unified theory called the vortex theory, which many people were working on. As Wikipedia's pointing out down there, Pearson's theory, this was before Einstein, required a fourth dimension for the ether to flow from and into. So you've even got the idea that this fourth dimension before Einstein, and all of that sort of thing gets ignored by the mainstream. So before Einstein, the unified physics theory attempt was the vortex theory, and I pointed out in one of my talks to John Chappell Natural Philosophy Society that if you want to discard Einstein, say he did lots of things wrong, then before Einstein there was this theory of, well, attempt to everything called the vortex theory. So ideally I would think that distance, if they all agree Einstein's wrong, they should then go back to this earlier theory, but they don't seem to want to. So I'm also pointing out now, so if you're saying Einstein's relativity is wrong, or better to say messed up, then go back to earlier physics would be the vortex theory. And I'm pointing out it is surprising that of the many dissenters with relativity, that most of them don't go back and reconsider the unified theory of vortices. That would sort of like really be common ground for us to further discuss things. If we sort of like all agreed Einstein's relativity is wrong, then let's go back to earlier physics. But dissidents don't seem to do that. Instead they just come up with their own pet theory, and they don't reconsider physics, which was pre-Einstein. So anyway, now given that Einstein's relativity is wrong in some way, as I've spent many videos on them, going back now to how antimatter was handled before Einstein's relativity gave changes to this concept, then obviously what we have now about antimatter is wrong. So you've got how antimatter was dealt with before Einstein, and now we've got how antimatter is dealt with after Einstein. And if you're saying Einstein's relativity is wrong, then obviously how we're now dealing with antimatter is wrong as well. But it's very difficult to get a handle on that because so much mess has been made by relativity. Anyway, I'm going to have a go. I'm trying to have a go at looking at antimatter after it's been messed up by Einstein's relativity. And so I'm going to have to wave my arms a lot. There's a lot of things I'm not able to go into in too much detail because it's all getting blurred by Einstein's relativity. So you could say antimatter originally conceived as having negative mass based on trying to combine special relativity of quantum physics, but that can be argued against, and we'll get to anon. But given that the physics establishment then changed it to having positive mass, this is another example of physics making a mess of things when dealing with relativity. Sorry for typing, having this twice. Obviously the spell checker didn't check that. So go back to Wikipedia once again. It says the modern theory of antimatter began in 1928 with Paul Dirac, and it goes on to point out it was picked up again further with Oppenheimer. So there was a transition from Dirac to Oppenheimer in the handling of antimatter, and it could be argued that when Dirac dealt with antimatter, it was possibly negative mass, but when Oppenheimer handled it, it became positive mass. I'm waving my arms. It's a bit dubious about that. Ideally, I need to check more details about that, but roughly that could be seen what was happening. So this is the main man where you get the antimatter form. It's Paul Dirac. He was an English mathematician and theoretical physicist who was considered to be one of the founders of quantum mechanics. Dirac laid the foundations for both quantum electrodynamics and quantum field theory. So started with, say, being a dissenter with Einstein's relativity and thinking it's a mess. You're then faced with Einstein's relativity, then gets combined with quantum physics. And so you then say, well, quantum physics is a mess as well. And so I'm just highlighting that and waving arms. It gets too complicated an issue to get into about quantum physics. And so the relevant equation for energy is this one, and this one comes from Einstein's relativity, where you have the capital E as representing energy, and that's in this case total energy, and you got the mass as being m, and that's sometimes called rest mass, but often it's just dropped now as just being called mass. And you got c as the speed of light, and you got p as momentum. So trying to put aside all the issues that complain about handling of mass, light speed and momentum and energy in the context of relativity, which I've touched upon in parts in the previous videos. We're just going to accept this equation for the time being and put aside all the issues of difficulty about trying to understand where this equation came from, because I think it's you look at Einstein's relativity, it's a mess. So just acceptance equation for the time being. And the surprising thing is that E is squared, and that's energy squared, and that's kind of like then treating it like a vector. Suddenly you've got from an equation like this, energy is looking like a vector. And before Einstein came along to mess things up, energy was supposed to be a scalar. So suddenly, somehow or other, you've got this transition between treating energy as a scalar to treating it as a vector. And that's all very confusing as well, but trying to put aside that issue as well. So going on, you could argue that if go back to vortex theory pre-Einstein, would have a different energy equation. But I'm putting that issue aside and just going to go with this equation, because we can get enough problems trying to understand this equation. And so when momentum is equal to 0, when p equals 0, you end up with this equation, E equals mc squared, and that's the more famous equation from Einstein, which most people know about, E equals mc squared. It's the early equation where you go back to it. This early equation that the general public is not so familiar with. The equation they're familiar with is when you're treating momentum as 0. And that's when you got E equals mc squared. So going back to this equation, which is the full equation for energy, which comes from Einstein, where you've got the energy squared. And so I'm noting here that you've got energy squared. It's really strange to have this term squared. It's strange to have energy E squared. It's strange to then have mc squared. That all term then squared as well. PC squared as well. So we're not used to squaring energy terms. But going by that equation, what we end up is a Pythagorean triangle. We can treat the thing, if I go to larger, right, so you can treat the hypotenuse of this triangle as the capital E energy, total energy, and one of the sides you can treat as mc squared, and the other side you can treat as PC. And so this is a Pythagorean triangle. It's really strange to suddenly have a Pythagorean triangle turning up in energy. And, exit full screen, right. So next slide, going on to the next one. So if we pick up from Pythagoras, it may not be known to students that Pythagoras was a mystic, and it was religion and mathematics combined. So he had a sort of a mathematical religious society. And the basic idea was that mathematics described physical reality, stroke the universe, stroke nature, and he was building on such things as triangles, among other things. So from Pythagoras, you have this idea of the Pythagorean triangle, and then that was supposed to apply to the rest of the universe, and he had lots of other things, other shapes as well, which are supposed to apply to the universe. But basically mathematics applies to the universe, and that's sort of like mystical. So going on with that, when we have this triangle, we can consider this coordinate system where you've got the y-axis of PC, and you've got the x-axis for mc squared, and you could put triangles in all of these four sectors, and then you would form these sort of triangles. You would form a triangle with the usual PC and mc squared as two of the sides. You could form a triangle with minus PC as one side and mc squared as another side, or you could form a triangle with PC as one side, mc squared and minus mc squared as another side, or you could form a triangle where the sides were minus PC and minus mc squared. So you could form these four triangles. And so the relevant word for this is that they are congruent triangles. If you rotate to this triangle about the coordinate system, and you could then form those four congruent triangles. So by Pythagorean thinking, then all four triangles should apply to nature stroke universe stroke physical reality. But mainstream physicists don't seem to think that way, and think in terms of only some of those triangles apply. Hence why mainstream physicists are getting things wrong. They're not thinking in Pythagorean terms. They've got in their mathematics these four congruent triangles, and they're not actually thinking in terms that all these four congruent triangles should apply to nature. So now going by the Santilli and his telescope, I've given a talk on him before. Santilli claims that using his telescope, he can see things which are not visible to normal telescopes. And that's because there's two types of light. There's an isodual light, which is congruent to ordinary light. And that's important out here. According to Santilli, there are two types of light: ordinary light, which you're familiar with, and a second type of light called isodual light, which is congruent to ordinary light. And that's kind of like what I've been talking about with these congruent triangles. Isodual light bends in the opposite way to ordinary light, and there's different properties to ordinary light. Normal astronomical observations have been set up the way Galileo's telescope was set up to deal with ordinary light, and so hence they're ignoring this ISO dual light to a large extent. So mainstream physicists have got the nature of light wrong, and in relation to that light they have got antimatter wrong as well. Mainstream physicists are just engaged in the building process of building one mistake on top of another, and sort of as I pointed out that it is building upon Einstein. So really you're just building upon mistakes upon what Einstein started. When thinking in terms of matter and antimatter particles, such as electron and anti-electron, they think of an electron with negative charge and an anti-electron with positive charge. And they're thinking in terms of both having positive energy plus E, and really should be thinking in terms of there being such things as negative energy out there minus E. And that's what you would get in these congruent triangles of energy that I pointed out. So somehow these physicists are not dealing with the full mathematics which they get from this energy equation. Santilli deals with these sort of things in his book, the isothermal theory of antimatter. And he's actually written many papers upon this subject. And so I want to show this video, which is an introduction to Santilli's work. Santilli has got a great many videos on the internet, and I was trying to look through them and decide which is the simplest one to start with. And this one is called A New Renaissance in Cosmology for Matter, directed by Giovanni Pace, and it's part 1. And so by the new Renaissance, it means that we've had to start again after the mess that Einstein's made. Modern physics starting from what Einstein did in 1905, and you have to have a new Renaissance to sort out that mess made by it. So it's a new cosmology. So basically everything got wrong in our understanding of like gravity, antimatter, etc., etc. And so mainstream just wants to push these sort of things under their carpet. They kind of exclude things which don't fit into their beliefs. So that's once again what they're doing with this mathematics. They're trying to think of it in terms that they want to believe in. Thank you. That's the end. I'll see if I can now get the video up for Santilli at this stage. So I'll remove myself and start playing the video. Hopefully I can get the sound right. I've got to silence myself too.
Back in the Middle Ages, people used to think that the Earth was at the center of the universe. Then came Galileo Galilei and proved that the Earth was orbiting around the sun. Nowadays, cosmologists believe again that the Earth is at the center of the universe because implied by the expansion of the universe. In recent years, an Italian-American scientist, Ruggero Maria Santilli, has proven that this is not the case.
Earth is not at the center of the universe because space itself is expanding, therefore carrying along all galaxies.
The answer to this important question will be provided by the Italian-American scientist, Professor Ruggero Maria Santilli, a former member of the University of Miami under research support by NASA, Boston University under research support by the United States Air Force, the Center for Theoretical Physics at MIT, the Department of Mathematics at Harvard University under the DOE support, currently the president of the Institute of Basic Research in Central Florida, the chief scientist of the publicly traded company Magnagas Corporation, as well as other companies. Professor Santilli is the author of about 300 papers published by journals of the American, Italian, and British Physical Society, as well as respected scientific journals the world over. He is also the author of 20 post-PhD monographs in mathematics, physics, and chemistry, and the editor of about 100 volumes of conference proceedings. Professor Santilli has been the recipient of numerous honors in various countries, such as scientific awards from Italy, France, and Nepal. The Grand Cross of the Sant'Agata Order from the Republic of San Marino, and the Mediterranean Prize also granted to Hillary Clinton, France President Nicolas Sarkozy, Prince Albert of Monaco, King Juan Carlos of Spain, and other famous dignitaries. Professor Santilli has also received over 100 nominations for the Nobel Prize in Physics and Chemistry by renowned scientists the world over. Professor Santilli's complete CV can be viewed by accessing www.world-lecture-series.org. Then click on Prologue.
The buck of academic politics stops here at the Sebring International Racetrack. Let me remember that in 1929, the American astrophysicist Edwin Hubble discovered that light reaching us from faraway galaxy is redshifted, namely the entire spectrum of light is shifted toward the red in an amount which is the same for all galaxies having the same distance from Earth in all directions in space. And moreover, the redshift increases with increase of the distance from Earth. This magnificent discovery has been, unfortunately, the victim of a real web of conjecture. Each conjecture proffered to cover a preceding unverifiable conjecture, all conjecture having a very, very specific aim, but it is an unspoken aim, that of imposing the validity of Einstein theory throughout the universe via the use or abuse of academic power. In fact, we first had the conjecture of the expansion of the universe in order to match the experimental reality, which is the cosmological redshift, with the theory, which is special relativity, the Doppler's law in particular. However, the expansion of the universe implies the Earth at the center of the universe as necessary from the very definition of the Hubble's law. Additionally, we had the conjecture of the acceleration of the expansion, but again, the acceleration is the same in all directions, therefore again the Earth at the center of the universe. And then we had the conjecture of the Big Bang, namely that the universe originated from a primordial explosion some 13.7 billion years ago. But again, in order to be compatible with the preceding conjecture, the Big Bang had to occur in our galactic vicinity. Therefore, the Big Bang implies again a return to the Middle Ages with Earth at the center of the universe. After all this conjecture, we had then the conjecture that you mentioned, namely that the space itself is expanding and therefore it carries along the galaxy during the expansion. However, we have to clarify immediately that, this additional conjecture did indeed achieve the objective of derailing attention from the consequence of the preceding consequence. However, the conjecture of the expansion of space itself, it cannot be claimed scientific in any credible way, because it does not provide a numerical, mathematical representation of all experimental evidence. Moreover, the conjecture of the expansion of space itself does not avoid the Earth being at the center of the universe, because of the acceleration of the expansion, and that it is the same in all directions of space. So even if space itself is expanding, the Earth remains at the center of the universe. Let us recall that Edwin Hubble, as well as many Italian Nobel Prize, Enrico Fermi and many others, they all died without believing in the expansion of the universe, because they could not accept, for their own dignity, they could not accept that Earth is at the center of the universe. In order to see the scientific obscurantism in cosmology in its proper light, let us recall that immediately following the beautiful discovery by Edwin Hubble of the cosmological redshift, the Swiss astrophysicist Fritz Zwicky proposed the hypothesis of the tire light, namely that light simply loses energy during its long travel to reach Earth, and by losing energy, as a consequence, as the redshift. In fact, the energy of light is given by the product of the Planck constant multiplied by the frequency. Therefore, any loss of energy by light implies automatically a redshift. Now, to see the gravity of the scientific obscurantism afflicting cosmology under a river of public money, there are at least 3 points to review. Number one, Zwicky hypothesis did indeed achieve a numerical, mathematically exact representation of all measurement on cosmological redshift without the expansion of the universe. Secondly, the Zwicky hypothesis was immensely more plausible than this chain and web of extremely far-fetched conjecture, including the idea that trillions and trillions of galaxies move away from Earth at ever and ever increasing speed, to the paradoxical limit, and now apparently galaxy at the edge of the known universe travel faster than the speed of light in vacuum. All this without any mathematical or physical or even concept indication of the enormity of the energy that is needed for all this expansion of trillions of galaxies and the acceleration of trillions of galaxies without any scientific plausibility whatsoever. Finally, to understand the gravity of the scientific obscurantism afflicting cosmology, we have to remember that that Zwicky hypothesis could be verified experimentally on Earth or disproved. By comparison, organized academic interest on Einstein theory, they imposed, by the abuse of academic authority, the validity of Einstein theories throughout the universe. And here is the key point: by a chain of conjecture, none of which is experimentally verifiable. So that's a very, very cozy situation for organized interest in Einstein, because they use the credibility of academia by a theory that cannot be verified experimentally. So therefore, as a result of this, the emergence of a serious scientific obscurantism of historical proportion cannot be denied by any ethically sound scholar. To cut academic politics out of serious science, in this documentary we shall present experimental evidence, I repeat, experimental evidence, published in referee journal other than journal in which I am an editor. I repeat, published in referee journal that cannot be ignored without losing dignity and credibility, according to which Zwicky original idea that light loses energy during long travel to reach Earth is indeed correct. Only the mechanism that was originally proposed by Zwicky is not the right one, namely scattering. We know today scattering cannot provide any redshift, let alone redshift of the order of hundreds of nanometers as needed for redshift. In particular, the mechanism according to which Zwicky idea is realized in nature is now known under the name of isoredshift, and was completely unknown during Zwicky time. Not even the mathematics for its quantitative derivation was known at that time. We shall present this comprehensive evidence by showing that the redshift of sunlight in the transition from the zenith, which is yellowish, to the horizon, which is red, about 100 nanometers, is entirely due to loss of energy by light to our atmosphere, with virtually insignificant contribution from absorption and scattering. As everybody knows, this redshift occurs without any relative motion between the Earth and the Sun, since the Sun just moves down, but the distance Earth and Sun remains essentially the same. In conclusion, the experimental evidence to be presented in this documentary establishes that the redshift of the Sun at sunset is visual evidence confirmed by comprehensive measurement that there is no expansion in the universe. In this documentary, we shall promote a return of cosmology to scientific sanity, which can be achieved in one way and one way only, by following the teaching of Galileo Galilei, according to which our idea must be first subjected to mathematically rigorous elaboration, and then subjected to an experimental verification here on Earth before we apply them to the universe.
My name is Carla Gandiglio Santilli. I'm spouse and partner in life, science and business. I'm quite familiar with the issues presented by my husband. It is important here to recall the teachings of the Neapolitan historian of the 17th century, Giambattista Vico, which are still relevant today. In his main work, La Nuova Scienza, he presented the fact that science, in order to move forward, has to go back to the original mathematical rigor and experimental verification on Earth. And this is exactly and precisely the teaching of Galileo Galilei, which must be implemented in cosmology in order to move forward.
You're looking good, you're looking sharp, you've come so far.
Gillette Labs, a razor unlike any other, for exceptional comfort and closeness in one effortless stroke. Gillette Labs, the best a man can get.
You've put everything in the dishwasher and then you see it. But then you find the new Pump Action Fairy Power Spray, enabling you to skip the soak, as it gives you the power of an overnight soak in minutes. Mission accomplished.
Looking back to 1982, the great philosopher of science, Karl Popper, published his last book that was called Quantum Theory and the Schism in Physics. There, Karl Popper, he stated that Santilli, quote, represented a return to the sanity and to the realism and objectivism which Einstein stood for. After 1982, very much happened with further advances in hadronic mechanics. That was the name of physics initiated by Professor Santilli, and transpiring into discoveries also in other disciplines. Today, this is a vast body of quite established scientific knowledge at the forefront. And 1 year ago, the main results was summarized and reviewed in a book published by Professors Gansa and Kadisvili. The name of the book was New Sciences for a New Era. New Sciences for a New Era. And in my view, one of the most far-reaching contributions from Professor Santilli was the discovery of a new class of numbers named ISO numbers, which could be represented by arbitrary units. Santilli was able to construct a new field of mathematics named ISO mathematics based on these novel numbers.
Hello, my name is Hermano Santilli. I'm the CEO of MagnaGas Corporation, a publicly traded American company. Here at the Michigan division, behind me you will see one of the hadronic reactors invented by my father and chief scientist, Dr. Ruggero Santilli. Our patented technology is unique. We gasify various liquids and liquid waste into a cost-competitive and ultra-clean burning fuel. This fuel has many applications. For the moment here in Motor City, we're successfully targeting the industrial gas sector.
Another exclusive feature of this technology is that it allows the production of MagnaGas fuel anywhere desired, thus eliminating the high cost of insurance and transportation of combustible gases, along with consequential decrease of storage costs. As an example, gasoline stations and car dealers can actually be turned into fuel producers via the installation of Dr. Santilli's hadronic gasifier due to their convenient size, safety features, and completely automated operations.
大家好，欢迎来到麦格尼茨分子技术北京有限公司，这里是 MagnaGas 与中国 DDI 公司合资成立的 MagnaGas 中国生产研发基地。我们拥有2000平方的办公大楼和3000平方的生产研发中心。
这就是意大利籍美国人桑蒂利博士所设计的自身的技术的成套设备。我们利用这套设备在中国做了大量的实验，包括市政的污水污泥采收垃圾，包括工业的废油、废甲醇、乙醇，那么也取得了巨大的成功。
727-934-3448 or visit our website at www.magnagas.com. MagnaGas, like no other.
Hello again. So let's see. I hope we got the same right. That's the introduction to Santilli's physics. I've been trying to look at the comments, and I get paranoid that looking at the comments was interfering with the video. What I see though, I don't really see anything. It's connecting to the this talk. It's sort of like talk between people. People saying things like the Big Bang doesn't exist and so forth. There's people been chatting among themselves, I think. So if there's anybody in the green room that wants to come forward, now's the time. Put your hand up, please, if you want to say anything. We've got we got one hand up already. It's James. Hello, James. Hi.
Hello. Well, I have several comments. I'll take them one at a time.
Okay.
You said that everything, a theory of that, you seem to characterize special relativity as a theory of everything. That's the first time I've heard that idea.
I didn't mean that. No.
You didn't mean that. Okay.
No, it's built upon it. It's built a building on it.
It's built on what?
Well, a lot of mainstream physics is now built upon things that Einstein said. It's built upon what he said about special relativity.
That's synonymous with a theory of everything, because mainstream physics basically doesn't have a theory of everything.
Well, they've got attempts at a theory of everything. It's a superstring theory and quantum gravity and things like that. But they're trying to incorporate the things that Einstein says into it.
Correct.
Yeah.
The next thing. Let's see. Oh, yes. You seem to make the statement that antimatter does not come from Einstein. Or, let's see. I'm trying to read my own notes here. Oh, yes. You were saying that the antimatter idea was not from Einstein.
Yeah, that's right. The antimatter was talked about before Einstein, and then he got the modern version of antimatter, which is common from Paul Dirac.
Okay, correct. Let's see. I have a note here: same mass but different types of energy. I'm not sure what that referred to in your talk now. It's been so long ago, about an hour.
Yeah.
Does that ring a
Okay,
bell, Roger? Or
no, not really. No, the mainstream seems to want to believe that antimatter has positive mass, and I pointed out the equation from Einstein: E squared equals such thing. You can seem to get the idea that there is negative mass in that equation.
yes, I'm not sure myself, Raj, about this whole idea of the Pythagorean triangle and squaring these things. If you write the equation without the squares, basically you're saying the energy, again, not squared, is the sum of mc squared, which I think most physicists would interpret as being the rest or ground energy, ground state energy or rest energy. And then the PC momentum factor would be the kinetic energy due to movement. And so that I think it all makes more sense if you consider the energy being the sum of those two values, the ground state rest mass energy and the momentum. And then in fact, the value of E, that sum, is greater than the value of E that you get when you consider E to be the hypotenuse of a Pythagorean triangle. Do you have any comment or view on that?
I was presenting that equation, which is E squared, capital E squared, equals to m squared c to the fourth, wasn't it? And plus p squared plus c squared. And that seems to be the basic equation which relativity has for that. And you can manipulate it around different ways. But taking that equation as it is without arguing about its derivation, you do end up with what is a Pythagorean triangle.
Okay, well, I'm not sure where relativity. I don't consider myself an expert in relativity, so I'll throw in that disclaimer. But I'm not sure where that squared equation, where a Pythagorean triangle interpretation of it all comes in or comes from. What the source? Who published that idea first, or whatever? What is the origin of that idea? It's not Pythagoras, because Pythagoras wasn't talking about energy and rest states and momentum at that time.
I was pointing out there's a Pythagorean triangle for energy, and given that equation, you can form that sort of triangle with it.
Well, that's precisely my question. Where does that equation come from? The squared version.
E squared is equal to m squared c fourth plus p squared c squared. That is in standard physics.
In standard physics.
Yeah, that's the equation that they give you.
In other words, we don't attribute that to anybody.
Well, I think
I don't really consider that, with all due respect, I don't consider that an answer to the question. I would have preferred that you don't know where it came from.
Well, it's supposed to come from Einstein. It's sort of like Einstein presented his mathematics, and then you derive the.
So there's a particular paper where that equation appears?
I didn't reference that. I didn't reference it. I presume it's taught at when it's taught at an advanced level at.
Well, I'm not trying to put you on the spot, man. I'm just saying that I don't know the reference and the origin of that equation, and it appears you don't either.
Well, it does.
I would humbly submit that my interpretation is much better. That drop the squares, and E equals mc squared, which is a rest energy term or a ground state, particle ground state term, and then the momentum pc, which is the kinetic energy part of it. And so that we don't have this Pythagorean triangle. That's what I would submit.
Well,
So anyway, the next point I have in my note. I'm sorry. Did you have a comment on that, sir?
I'm looking it up to see where it says for it.
Oh, okay. The internet, ladies and gentlemen. He's looking it up in real time as we as we breathe, ponder,
Yeah.
dream.
I'll bring this
right
this.
now.
I'll bring this up. So if I can hold on. That's that one finished. Get back to that. So remove that one.
Well, if you can find who is to, shall we say, who is to blame for this squared version of the equation, that might be an interesting point.
I don't
Rather
know
than
who
just
to
saying
blame.
we don't know where it came from.
I don't know who to blame, but it is referenced at places. So, share screen.
So nobody knows where it comes from, but they reference it. That's sort of funny. That's sort of
I haven't looked back to see where the equation comes from. So hold on a minute. We bring you down and bring me down and try to bring stage again. Okay, so hopefully that clarifies some things for you.
Well, actually, it doesn't.
Doesn't.
What we needed in that first part of what you were showing there was reference 26 and 27 were apparently the origin of this sort of possibly bogus idea of using the Pythagorean theorem, because that simply seems to violate the conservation of energy, which is one of the most fundamental laws of physics. And they cited in that first part of what you showed references 26 and 27 of that Wikipedia article. What article was that, so that we can look that up again?
That's Wikipedia on the mass energy equivalence.
Mass energy equivalence. Okay.
Yeah.
Well, that reference 26 and 27 were their origin that they cite for the author of that cites for that idea, which I think is a bogus idea because it clearly violates the conservation of energy. And unless that is discussed somewhere and addressed, it's an entirely bogus idea. Okay. I mean, it has no scientific merit, whatever. And
I think dissidents have pointed out their protest at that equation from.
Well, you don't have to be a dissident. That's the conservation of energy is a principle in physics that the mainstream accepts. Okay, so the fact that people are putting forth this sort of equation and pretending or alleging or asserting that it has some physical meaning without discussing the fact that the equation itself violates the conservation of energy shows to me that these people who are ever doing this sort of really don't know what they're doing, that they're sort of like lost sheep.
I think
that's my way to put it cruelly.
Well, no, this is from the mathematics from what Einstein started with special relativity. They sort of manipulate
that's what reference 26 and 27 point to?
Sorry?
Well, they cite reference 26 and 27.
There's lots of references there. It would take a lot of digging through to see precisely where things are coming from. But roughly, I wasn't going into criticizing that equation. I was just taking it as it was, because from a distance point of view, you would sort of like criticize that equation, because if you don't accept special relativity and an equation like that coming from special relativity, you would kind of criticize. But
I don't view it as an issue of whether or not you accept special relativity. I view it as an issue of whether or not you accept the basic idea of the conservation of energy in physics. It has really nothing to do with relativity. When you drop an equation and give it any credibility at all.
Yeah, I wasn't attacking it from that perspective. I think people who attacked it from that perspective, you end up with the idea that is recognized there is a conservation of energy problem there, and that's when they introduce a neutrino to compensate for that. And I think David de Hilster goes into a lot about that, complaining about this idea of a neutrino is just a bodge to conserve energy. You get the basic equations like that from relativity, then you get this idea of adding a neutrino to save the theory and get your conservation of energy back again. But I wasn't going into that.
I guess I've made my point, and I won't belabor that anymore. I have one last point.
It wasn't the point of this video to attack that equation. It was just to try to make sense of what that equation was giving in terms of antimatter. And so, unfortunately, mainstream physics, I think, do accept that equation to a large extent.
Well, that was my last question. That was my last question, Raj.
Yeah.
This idea, I seem to recall that a anti-hydrogen, some sort of an anti-hydrogen atom was captured somehow in a laser matrix that holds particles in place, and that there was a demonstration that it's that this antiparticle or anti-hydrogen atom, of which apparently there are several different ways to do it, different kinds of anti-hydrogen atoms. But anyway, that it had a positive mass. And so my last question or last point was your mentioning of the possibilities of negative mass and positive mass. That it's on. My question was, what is the evidence for positive mass, or even for negative mass, for that matter? But it seemed to me that I'm recalling. I'm sorry, I don't remember the specifics of the experimental report, but that this anti-hydrogen atom object was thought to have been shown to have a positive mass, and I'll leave it there.
Yeah, that's right. So thank you.
And thank you, Raj.
Thank you. Okay, thank you. So the problem is that the equation which they're using, which many distance disagree with, it does give you this idea that there is negative mass in there. So when these experiments are finding that it's positive mass, but that's only part of what the equation has. It has these extra things in it. It has more than just the idea of positive mass particles. It's also got the idea of negative mass particles. So in this equation, in theory, you could construct a negative mass antimatter, and the mainstream doesn't seem to be considering that. They're just going for this idea of positive mass antimatter. So thank you, James. Next hand up is I think it's Dennis is putting his hand up, so I'll bring up Dennis now. Hello, Dennis.
Hi.
Thank you.
You were just showing the article on the screen. The relativists claim that energy conservation is old hat, as I understand it, is old hat, and what you have is a complicated energy momentum conservation instead.
Sorry,
so in other words, they don't worry that it's energy is not conserved, because there is something conserved, and that's the energy momentum tensor or something of that. So they're not. If you say to them energy is not conserved here, they say, yeah, well, you've got to get with it. Nowadays, we worry about conservation of the energy momentum tensor, not energy. Energy is, for people who aren't too bright.
That's part of the building process, because Einstein started with his special relativity in 1905, and then further on he built on more and more on top of it. 1915 they've got general relativity, and that gets built upon and so forth. And then they talk about mass energy. You have to combine two things together to conserve them. And the mass energy and so forth, warp space-time. So it's further on in the chain of building that they engaged in.
And they refused to give up general relativity, even though Van Flandern, an astronomer, wrote a book where he pointed out that the far out planets of the solar system, like Neptune, if, as predicted by general relativity, a gravitational force was transmitted with velocity c instead of almost instantaneously, that these planets would wander off into space. So it can't be that if you do the math, you find you can't have gravity propagating at velocity c, which is what general relativity predicts. But the people that still use general relativity say, well, that may be, but we aren't worried about planets out as far as Neptune. We're working at, for example, there's one fellow who works at, builds electron microscopes, who endorses general relativity as far as his company for producing these electron microscopes is concerned. I'm trying to think of his name. Vivian Robinson, I think is his name. He said, Australia. Yeah, I've been in touch with him a little bit, and he's adamant that the general relativity is right, and he's building instruments, delicate instruments that you would think that they wouldn't work right if we used the wrong theory to produce them.
Yeah.
But they do apparently. It's just that they don't. Since your an electron microscope is not the parts are close together. The fact that general relativity doesn't work for planets way out in Neptune, it doesn't really come into the picture because the parts of the microscope are close to each other, whereas Neptune is way out there.
Yeah, I don't know about this Neptune thing, but Einstein's relativity does have all these things added to it, sort of like dark matter and dark energy, because they're making observations which don't straight away fit into Einstein's relativity, and so they've got to add an extra bit to it, and so it's all part of the building process.
Yeah, it's it's sort of a pragmatic thing. Use what works, and don't worry about if if it doesn't work in some other situation, and so what? If it works in your situation, be happy.
Yeah. So they claim with their theories nowadays that they have a range of range where theories work, and so if you kind of push them on things, they say things like Einstein's relativity has a range of application, and we've done our tests, and that theory works within those range. And then if you look outside that range, sort of like further on, then you have to add extra things to the theory, sort of like that, like dark energy and dark matter, to try to get your observations to fit with the theory. So it's all part of the building process.
Yeah.
And I call it moving goalposts, but that's when I've argued with a few people about that now, philosophers and of science and so forth, and it's an actual part of theory for it to evolve, to get more added to it, and so that seems to be what happens to Einstein's relativity. More things get added to it, and it's supposed to be a natural process of evolution of the theory.
Yeah.
So what I complain about is the building process, and you're building on a mistake, so you're just adding more mistakes on top of it, each thing. But
or you just say, well, it doesn't work in general, but it works where I'm concerned if I'm building something like an electron microscope. So why should I worry that somewhere else it doesn't work?
Yeah, certainly. So if you build an electron microscope, presumably you got the mathematics which you've managed to adjust to make it to work.
Yeah, it's the same thing in climate change and so on. Two American scholars, Professor Emeritus Will Happer of Princeton and Professor Emeritus something or other who I couldn't pronounce, MIT went to before Congress and pointed out that climate change models that they're using don't give the right answer. And finally they conclude by saying the whole thing was a scam. Someone that honest, I've been in touch with Happer too, and pointed out that Happer's and his team, before he retired, developed what's known as the spin pump laser, where the idea being you spin up electrons, which are already spinning, but you spin them up faster, so that then you stop spinning them, and as they move back down in equilibrium, they emit light, which is laser light. So I sent him I and Dave Bergman stuff and pointed out some things that were wrong with special relativity and general relativity, and he wouldn't accept it. But even when I sent him Ron Hatch's paper on, on a new theory of gravity, where he objects to special general relativity, which is the usual theory of gravity, and also special relativity. In one paragraph, he objects to that too. And he sent back an email saying, "Well, if Hatch really understood this and that, then he wouldn't have said that." But Hatch knew what he was doing. He's the reason why GPS is so incredibly accurate. Before he came along, if you had GPS in your car, you had two right turns, one right next to each other. The thing wasn't accurate enough to tell you which one to take. You had to take one or the other, and then if you weren't getting to where you were going, you have to turn around and go back and take the other one. But Hatch now, it's down to centimeters that they, and yet he would. Happer would not accept Hatch's ideas.
Well, the thing with Ron Hatch, he wasn't trained in Einstein's relativity, and he wasn't using it.
He knew Hatch knew about Einstein's relativity.
Yeah, but he wasn't using it. He didn't have it.
He pointed out that the equivalence principle was wrong.
Yeah. But what I gather that when he was doing the GPS, he wasn't using Einstein's relativity, and he hadn't really been taught about it. So he was coming it from not having to use it. He hadn't been taught it, so he didn't use it, and so he wasn't really an expert in relativity. And I've gone to lots of physics talks about things like in Oxford. There was an expert on GPS from relativity, and he said he'd studied the data which you get back from the GPS, and he says that fits in with relativity.
Oh no!
So
Ron Hatch was working on a paper, which he sent to me and asked me to comment on, called tolerable asymmetry. As it was attacking special relativity, where it has complete symmetry. It's not antisymmetric, and any inertial system is fine as far as special relativity is concerned. It's completely symmetric. Well, he wrote this paper. He was writing this paper and had pretty much it all the way finished, called Tolerable Asymmetry, and which pointed out that special relativity was wrong. You can't use any inertial system you want.
The trouble is that special relativity, you can start off with special relativity, then you do the add-ons, because it's, the theory gets built upon to give you general relativity. So if you're doing an experiment and it's not fitting special relativity, they then say you need to put good add-ons to it to make it more fit in with the rest. So it's the add-ons to relativity is what's saving it.
Yeah.
But in the case of this relativity expert, he was the only one that I knew who had looked at the data of GPS, and he looked at it and decided it does fit in with Einstein's relativity, and that's taking into account special relativity, general relativity, and all the other add-ons you add on to it to the theory, and you look at the data and say, oh yeah, that fits with what Einstein's talking about.
I don't think so. Ron Anderton, the day he died, said that was not true.
And what I've been talking to this other person, a physicist, Matthias, and he says he's been talking to Ron Hatch, and he's saying that Ron Hatch was changing his mind come the end about things. So you got all this confusion that's thrown up all the time. All the confusion is what's saving Einstein's relativity. You got the people like Dowdy, I forgot his name, who pointed out that Einstein's relativity has been mistranslated from German into English. And so I've looked into that, and I thought, I agree with that, yeah. So they haven't even got the theory translated in the first place. The initial thing you got to do is go from what Einstein actually said, and they haven't even translated it properly. So it's all been building process, keep building on and on. So that's the way it is. There's all the mistakes keep getting built upon. And in the case of relativity, they keep adding things to it to help it to fit into experiments and so forth. But today's talk was mainly about this equation, which Paul Dirac was using, where he seemed to get the modern version of antimatter. And it's sort of it's a confusing mess to try to make sense of it, because mainstream doesn't seem to want to look at that mass properly. That equation does give you negative mass, so there should be negative mass things out there. Okay, thank you. Just finished.
Yes, thank you.
Thank you, James, Dennis. You brought some good points up. Thank you. Oh, I got another hand. If you move, another hand coming up. Hi, Franklin. Hi, Franklin.
Good morning.
Good morning, Franklin. Good to see you again.
You're talking about antimatter.
So yeah,
and you're saying that this all came out of Dirac and kind of his.
That's the modern version of antimatter. That's modern
of mathematics. Although I've been playing with people in the comments, there are people who actually doubt the existence of, say, things like positrons, for example. People didn't realize that we have been able to actually create antiprotons along with the positrons, and have actually been able to make antihydrogen.
Yeah.
And the properties of these anti-atoms are significantly different and can be separated from normal hydrogen. And they're really tricky to keep around, because apparently if your anti-atoms run into any normal atoms, they annihilate, they blow up, they turn into photons.
Yeah.
So, I just wanted to bring out that point that antimatter, it is a real thing. We use positrons in medicine. I believe there's the thing called, positron therapy. We can also create, so we can definitely create antimatter beams. They have one of our main particle accelerator experiments generates a solid beam of positrons, and we collide them against a solid beam of electrons. And if they were the same thing or didn't exist, then obviously they wouldn't work, right? So as just this basic topic, for people wondering whether that exists or not, I would say that there is heavy experimental evidence to say that they do. But I also wanted to bring up one of the main mysteries about antimatter is that the big question is like, where is it? That according to Big Bang Theory, as much antimatter should have been created as matter during the creation of the universe.
Yeah.
It should have all just immediately annihilated, leaving us back with nothing.
Mm-hmm.
But yet we are left with the universe, which appears to be composed of entirely normal matter.
Mostly
right?
matter. Basically normal.
That's one interesting question. I have a possible answer to that.
Yeah.
And that I would say that, well, presuming there was a Big Bang, and I'm highly skeptical there was, but assuming that there was some starting point and as much antimatter and matter was created in the beginning of the universe. And the one piece of antimatter that we do know and recognize is the positron. So I would say that during the initial creation, it is true that as many positrons were created as electrons. So anything that was primarily made out of positrons would become antimatter, and anything primarily made out of electrons would become, I don't know, normal matter. But the way I see it is that the antimatter is basically anything that's positively charged. So like, where did the antimatter go? Well, I mean, I was discussing in the comments that, you know, in my personal pet theory, you know, I'm not saying that this is necessarily true, but a proton would consist of 2 positrons and 1 electron. So what happened is that all the antimatter just went into the proton. So, and that the total numbers of matter and antimatter is actually still even. That's why the universe in general is neutrally charged. Yeah. Because all those positive charges have been wrapped up into the protons, and we only see, say, free electrons. We don't see free positrons generally, because they're all stuck in the proton. Although that would beg the question, why is it that everything decided to bunch up into 2 positrons rather than 2 electrons? See, and that I don't have any answer to. I don't know why the matter antimatter would kind of get together in that way to favor 2 positrons and 1 electron. You know, and once again, this is presuming you don't believe the mainstream explanation for a proton, which is that it's like fractional 2/3 plus 2/3 minus 1/3. That equals 1. It's very complicated, even though we've never ever actually seen,
I think it's all about quarks,
an individual quark or any evidence of anything fractionally charged. We have never, ever seen that. So, you know, there's a lot of doubt about, you know, how the proton is constructed and how, say, the neutron is constructed. Yeah. You know, some people are saying that the neutron, for example, is probably a proton with an electron. But you know, I would argue that, well, you just named hydrogen. I mean, that's what hydrogen is. So yeah. And neutrons are definitely different from hydrogen, because we can create beams of neutrons, and they definitely react differently than hydrogen. And me personally, I just think that that's more complicated than necessary, because we know a neutron has a neutral charge. And what would be the absolute simplest way you could create a neutral charge? I would say it would be take a positron and an electron, put them together. That would be neutrally charged. So that would be the simplest composition for a neutron in my mind. You know, so that's why I like that particular hypothesis, that everything is just made out of the positrons and the electrons as antimatter and matter getting together in a logical way. So I don't know what you think of that, but that's kind of my thoughts on antimatter.
Okay. Thank you. They do have mysteries still, which are not solved. About why there's inequality matter and antimatter. Okay, so it's ongoing mysteries. Thank you. Is he finished?
All right, thanks.
Thank you. Okay. We move. Right. Okay, I'm back again. Oh, so James putting his hand up again. Okay. I think you can attack the equation again. Okay, James. Hello.
Just a real quick comment. I would like to point out that the 2 references that were cited when this squared equation, Pythagorean type of situation equation that you presented, the 2 references in in the Wikipedia article were references 26 and 27, and I looked those up. And they just refer to books written in 2006 and 2009.
Yeah.
So in terms of for me, it's still a little bit of a mystery as to what the origin of this equation is. And my second and last point is that the original equation without the squares, in other words, E equals mc squared plus the kinetic energy component, Pc, that's a mathematically incorrect in a way, because if you square the E, you need to square the other side. And by squaring the other side, you don't get what that equation shows. In other words, they converted the equation into a Pythagorean form, which was a giant step to do, and that requires a particular justification, because if you square both sides, you still get the sum of the total sum of energy equal to the when you then take the square root again of the rest mass mc squared and the momentum. So I just wanted to add that mathematical point, that they didn't correctly, when you square E on the left side of the equation as it was presented in the slide, what on the right side is not the square of the right side of the equation. It's the square of the individual each of the two components on the right side, which is not the same as the square of that sum on the right side, mathematically speaking. Thank you. That's the additional point I want to add.
Well, I wasn't getting into the issue of arguing about that equation. I was just taking it as it was. Okay, thank you. Finished? I'll move you. Thank you.
Yeah, thank you.
Thank you. Bye. Okay. I think anybody else going to put their hand in the air in the green room? Nobody else. We've got James, Franklin, Dennis, and Vladimir. Vladimir's not seem to say anything. Normally get Harry turn up, and he's left me alone today. So I think look in the comments a bit. Most of the comments are between people, so private chat between them. Not really seeing anything in the chat. People complain about Big Bang. Jay complaining, I think, Big Bang, the center of the universe. So, question saying, I'm skeptical of the existence of photons. That's skeptical of like particles. So there's just too many things to complain about when you start looking at Einstein's relativity. Okay. What matter? Don't know. Okay. I mean, what time is it now? Can't see the time. I think it's 25 to 5. I'm happy to close early. I think I covered all the points. I gave the basic problem with this equation where you're deriving the idea of antimatter from. I've done a video. Show the video of Santilli, Professor Santilli, dealing with his complaints about mainstream physics. And he's proposing all these things like tide light and all that. Because if you've got the expansion of the universe, that's interpreting the Doppler shift as a movement. But another way of interpreting it was as the light's getting tired and losing energy. So if it's tide light and not Doppler shift being motion, then that gets rid of the idea of the expansion of the universe. at the moment, the Doppler shift of these galaxies is interpreted as showing motion, and that motion is then taken to mean that there's some expansion going on. So it would be quite a revolution in cosmology to suddenly decide that all this building upon Einstein is building upon lots of mistakes. But in the case of, say, something like antimatter, it's Einstein gives his theory 1905, and in 1919 it's supposed to be confirmed by the bending of starlight, and then somebody like Dirac comes along later and says, "Oh, I can get this idea of antimatter from the maths that Einstein's presented," and then further on down the line, somebody comes along and says, "Yeah, I've done the experiment and I've got antimatter," and so it all looks like confirmation of the theory when it's a building process like that. But I say there's fundamental problems in understanding, even from the initial bit when you're building the theory from what Einstein's saying in 1905. And I've got another hand up. Dennis has put his hand up. Okay. Okay.
Dave Bergman and I, mainly Dave, invented the way to model electrons as a negative charge moving in a donut shape with various charge densities. And then I went from there to model the proton and also the positron after he died. And I tried to model the positron as something having negative mass, and I wasn't able to do it. Our model did not include any particles with negative mass. Of course, this doesn't prove anything because, it's just a model. But I think it's worth pointing out that negative mass just doesn't seem to work in physics.
I don't know what mathematics you were using there, but it's, as I've taken it, it's a problem in building upon what Einstein's saying. So you're supposed to have had that equation for capital E squared is equal to such thing. It was supposed to be from what Dirac got is antimatter. And so that equation is open to having negative mass in there. But based upon experiments, the mainstream is saying they haven't found that negative mass. So when you're saying that there's problems with a model based upon negative mass, I don't know whether you're incorporating that equation or not.
Yeah, just the negative mass just doesn't seem to work very well. Not just in our model, Dave Bergman, my modeling, but throughout all physics, negative mass is, leads to absurd results.
Well, I don't know what you mean by absurd results, because if you saw like you had this idea of negative mass and you put it into Newton's universal gravity equation, that at the moment we're using mass as positive in that equation. But if you suddenly said, well, sometimes mass could be negative, then in that placing it into that equation, you are getting repulsion as well as attraction from gravity.
Negative mass and positive mass would repel each other.
Yeah.
And furthermore, if you don't worry about gravitational mass, if you worry about inertial mass, if you push against a particle of negative mass in mechanics, then it pushes back even harder. At least, it doesn't. The force, the particle accelerates in the wrong direction when you apply a force to it. It's in the reverse direction.
Yeah.
So if I apply a force somehow to a positron, it should move in the opposite direction that you would think.
If it had negative mass, yeah.
So whether you look at it as inertial mass or gravitational mass, it doesn't work either way. I mean, it's a bad idea.
Yeah, I think it's sort of like when you're dealing with inertial mass and gravitational mass, you're assuming they're equivalent or not, because that's one of the things which you can start talking about with Einstein's equivalence principle, where the proposal is it takes several different forms. You've got the weak form of the equivalence principle and the strong form, and you're sort of like proposing whether inertial mass is the same thing as gravitational mass or not. But if you decide they're not the same thing, then you can sort of
Ron Hatch in his paper, New Theory of Gravity, published in 2007 in Physics Essays, pointed out that neither special or general relativity theories could possibly be correct. Just
based on GPS, is it?
Well, yeah, it's based on GPS, but it also, he showed that it led to ridiculous results.
Yeah. Okay.
And furthermore, the equivalence principle isn't right, because gravitational mass and inertial mass transform differently under increase in velocity.
Mm-hmm. Yeah, it's another issue to complain about, the equivalence principle. So you got, from Einstein, we got all these different principles. You got the relativity principle, the constancy of light speed principle, the equivalence principle, and you got all these other add-ons like the relativistic mass, time dilation, and length contraction, and so forth. You got so many things on top of it. There's so many different.
Yeah, when it turns out that time dilation is because cesium clocks don't tick at the same rate in a heavy gravitational field or when they're traveling rapidly with respect to the local ether.
Yeah, that's when you're taking gravitational time dilation. But when you've got special relativity time dilation, you seem to basically ignore the gravitational bit in that consideration. So it's all adding on. Okay, thank you. Okay. Any more? Thank you. Okay, bye then. Cheers. Oh, yes, another hand. Oh, not getting a chance to finish early then. So we move from stage. Add to stage, right. Hello, thank you. Yes.
Thank you. I think Dennis brings up the very interesting question of, what is antimatter,
Yeah.
And, he was trying to think that, well, maybe it's like negative matter, or other people trying to say it's an inflow and it's an outflow.
Yeah.
But it's a very difficult problem. And also it gets to the question of, what is charge itself? I mean, if you have a positron, it has a positive charge, and there's an electron, it has a negative charge. What on earth compels them to be accelerated towards each other? Right? That in itself is a huge mystery. Right? Now, I'm just saying that anything that's antimatter is anything that has positive charge in it, basically. That would be my deal. And for example, some people have said that, for example, if there's some ether and the positive charge is spewing out something and the negative charge is eating it up. And so that explains why they would come together, because, you know, the electron is just hoovering up the proton. Well, that's fine. But what happens when we have like two electrons? Then we'd have two hoovering things. And then you would think the two electrons must attract each other. And they don't. They repel each other just as strongly as two positive charges. So it's like any kind of property that you could give these things, it can't have any kind of directionality to it, you know. So that's why these theories of it being like a flow of something, that they just don't work. Another interesting thing that people were thinking is that the gravity effect of antimatter would be opposite. So they would think that antihydrogens would fall up. But they have actually done this experiment, and antimatter falls down. Just the same as regular matter. So
that's antimatter positive mass.
So they don't have any difference even that way.
Yeah.
But it's an incredibly difficult problem to have two things that have this property that alikes repel. I mean, alikes repel and opposites attract, no matter which pole you're looking at. So, but just in case you're interested in how I solved that problem, I actually think personally that the positrons and electrons are actually exactly the same particle. Physically, they are the same thing. The only thing that's different is the phase which they ring at. Now, for me, the only way that any one particle can affect another particle is by physically hitting it. Right? That's Newtonian law. Just like in a billiard table. So I'm very partial to anything you can explain on a billiard table. And so the only way that we can get positron electron to be heading towards each other is if something on the outside is pressuring them to come together, or there's like a low pressure between a positron electron and a high pressure on the outside. See, that would be a physical explanation for where they come together, right? Just like if you stick a vacuum cleaner to a ping pong ball, what's happening is that the higher pressure on the outside of the ping pong ball is what's actually pushing the ping pong ball towards the vacuum hose, right? That's a physical thing. And in order to get this charge attraction, you need that. You need to have something pushing. That's the only force that's really allowed in Newtonian physics is a push force. And the only thing I could think of that matches up is actually, if you think about phased waves, because we know that if you have two waves which are in phase and they meet each other, they'll add up, making bigger wave, higher pressure. And then we have the opposite, that if you have phases which are completely out of phase, then when those come together, they neutralize. This is how our noise canceling headphones work, for example. They create an exact phase which neutralizes the incoming wave. So, but I use that to try to justify how these forces work. Because if you have two positrons and they are ringing at exactly the same phase, then the waves between them will become bigger, higher pressure, and that's what pushes apart two positrons. And then if you think about electrons, same phase, that is exactly what's going to happen. So both electrons and positrons would repel each other, right? So we get that symmetry at least, right? You don't have this problem with one sucking and one spitting something out, right? You got to make it so that both types of things repel each other. But the thing is, if you got opposite phases going, one is going one and is going one, like this, opposite phases, then the waves that are happening between the particles, they're going to cancel, which means low pressure between them. That means that anything oppositely phased is going to shove each other together. So, that's one possible way. to get at least the symmetry that you need so that opposites attract and similars repel. The only thing that I can think of is like a phase interaction. But like I said, that would make positrons and electrons actually just exactly the same particle. It's like when the universe was born. I also think that time and space is quantized. So the electron is ringing at its fastest possible rate, and it only had two choices to take because time and space is quantized. So half the universe turned into positrons, the other half turned into electrons, and that would justify why is it that it should still be a 50-50. Everything in the end is neutral kind of deal. But but it is an important question to ask. What exactly is antimatter, and what makes a positron positively charged, and what makes an electron negatively charged? Now, that's generally speaking, we don't have no mainstream answer for it, and that's why us, dissidents are dreaming up our own ways of trying to figure that out. But it is an important question.
Mm-hmm. Yeah, whatever charges, we don't really know. It seems to be introduced by people like Coulomb and that, and Benjamin Franklin, maybe. It goes back much further than relativity. Okay, thank you.
But yeah, it looks like we're getting close to the end of our time anyways.
I think so. What time is it now?
Thanks for indulging me.
5 minutes to go. 5 minutes to go. Yeah, if my clock's right up there. Oh, we've got clock. Oh yes, 16:54 on my computer. Okay, thank you, Franklin. So I'll just sum up then. Thank you. Cheers. Okay. Let me move you. Yeah. How do we move? How do we move? Let me move. Cheers. Thank you, Franklin. Okay, so I think that's the end of today's talk. You got everything. Well, in my view, the mainstream have about physics. Most of it, mainstream physics nowadays, is coming from Einstein, and it introduced a lot of things to argue about. Okay, thank you. Cheers. Good night. Bye then. See you next time. Bye. Ending stream now.